Hello everyone, in this video we're going to talk about another theorem in geometry called the Reflections and Intersecting Lines Theorem. In a previous video we did a demonstration on the Reflections in Parallel Lines Theorem, so if you want to look at that, you look up in the top right hand corner of this video and I'll put a link to that one. So Reflections and Intersecting Lines says that if lines A and B intersect at point C, so we have line A, we have line B, they're intersecting down here at point C, then a reflection in line B followed by a reflection in line A is the same as a rotation about point C. So we're starting here with this line right here, line EF, and we are reflecting it over line B to get line E prime F prime, and then we reflect the line again, the line segment, to get E prime prime F prime prime. So to go from our pre-image or our original line to the ending line, we can say instead of doing two reflections, it's actually a rotation about point C, this point right here. And there's a relationship between the angle measure that's formed between the intersecting lines and the angle of rotation that we use to perform this rotation. That's what it says down here at the bottom. It says the angle of rotation is 2x degrees, where x is the measure of the acute or right angle formed by lines A and B. So this intersection, this intersection down here, which causes this angle x degrees, whatever the measure of that angle is, the measure of rotation, the angle of rotation will be twice that measure, okay? And so we can use this rule to work both ways, right? If we have the measure of the angle of the intersecting lines, then we can double it to find the angle of rotation. Or if we have the angle of rotation, we can divide it by 2 to find the original measure of the angle. So we're going to look at two examples, one of kind of each of those scenarios. So example 1 says, in the diagram, the pre-image is reflected in line R, then in line S, describe a single transformation that maps the white figure onto the pink figure. So we're starting down here with the white figure, we are reflecting here, and then we are reflecting once again. So our theorem told us that this would be a rotation about point, and we'll call this point T, forgot to label that, about point T. And now we can look at our angle measurement that's formed by the intersecting lines, double that to get our angle of rotation. So a rotation about point T, 124 degrees, right? 62 times 2. All right, so that's how we would do that. If we start with the measure of the acute angle, we double it to find the angle of rotation. All right, example 2 says a rotation of 80 degrees maps point B to point B prime. To map point B to point B prime using two reflections, what is the measure of the angle formed by the intersecting lines of reflection? So notice how this one, they give us the angle of rotation. We need to work backwards to find the original angle measure that's formed by the intersecting lines. So we have the part that's 2x, so we need to find x. So if 2x is equal to 80, then we know, hey, we could divide by 2 and we get x equals 40, right? So the original angle measure for the angle that was formed by the intersecting lines is 40 degrees, okay? And that is the Reflections and Intersecting Lines Theorem.